Hello students, here is math lesson 80. This is on page 413 in your math textbook. Today's lesson is talking about using a constant factor to solve ratio problems. Okay, it sounds confusing, but it really isn't. So let's take a look here. This is right from your book. The concept of this: consider the following ratio problem. To make green paint, the ratio of blue paint to yellow paint is 3:2. For 6 ounces of yellow paint, how much blue paint is needed? Okay, hang on, because this actually is way easier than it probably looks. We see 2 uses for numbers in ratio problems. One use is to express a ratio. The other use is to express an actual count. A ratio box can help us sort the 2 uses by placing the ratio numbers in one column. So here's a ratio box. That's what they're talking about when they say that. That's the whole thing. But we place the ratio numbers in one column. So there's the ratio. The ratio of blue paint to yellow paint is 3:2, and the actual counts in another column. We write the items being compared along the left side of the rows. So we identify that blue paint, there's 3. For every 3 units of blue paint, we have 2 units of yellow paint. We are told that the ratio of blue to yellow was 3:2. We place these columns in the ratio column, assigning 3 to the blue paint row and 2 to the yellow paint row. We are given the actual count of 6 ounces of yellow paint, which we record in the box right here. We are asked to find the actual count of blue paint. So we want to figure this out. And so that box is empty. Ratio numbers and actual counts are related by a constant factor. That means it stays the same, constant. If we multiply the terms of a ratio, so look down here at the box. If we take the terms of the ratio, which is 3:2, by a constant factor, we can find the actual count. Recall that a ratio is a reduced form of an actual count. What is that really saying? This line, do you know what that's really saying? This is saying our fraction, which is our ratio, is a reduced form of actual count. What is that saying? That's saying that that's simply a reduced fraction of something with 6 as the denominator. If we can determine the factor by which the actual count was reduced to form the ratio, then we can recreate the actual count. Okay, let's just make this super simple. Here's what we're looking at. We've done this a lot during the course of the year. What do we do to 3/2 to make it a fraction with a denominator of 6? Well, what do I do to get 2 to make 6? I multiply it by 3. So I have to do the same thing to the top. We've done this before, you guys. This is just a different way of setting it up. Now we're calling it ratios and trying to figure out the actual count. What it really is dealing with a fraction, which is our ratio, and then multiplying it by 1, because when we multiply by 3/3, that's multiplying it by 1, right? So I'm going to keep reading here from your textbook. We see that 2 can be multiplied by 3 to get 6. So 3 is the constant factor in this problem. That means we can multiply each ratio term by 3, which is exactly what I just showed you right here. Multiplying the ratio term 3 by the factor 3 gives us an actual count of 9 ounces of blue paint. And you might wonder where we got the ounces at. Well, if we go back to our original problem, look at our original problem. For 6 ounces of yellow paint, how much blue paint is needed? The answer would be 9 ounces. So let's take another look at another example. Sadly, the ratio of flowers to weeds in the garden is 2:5. So that means for every 2 flowers, there's 5 weeds. That's why they use the word sadly. There are 30 flowers in the garden. About how many weeds are there? We begin by drawing the ratio box. So the reason why we want to label the things over here is so that we get these numbers in the right places. But really what we're looking at is simply fractions and wanting to make equivalent fractions. So we look at this and we say, okay, what do I do to the 2 to get to 30? Well, I multiply it by 15. I have to do the same thing to the bottom, the denominator, because this is multiplying it by 1, right? 15 fifteenths is like 1. So I'm not changing anything, I'm just making an equivalent fraction. So 5 times 15 would be 75. So we go back to our problem here. There are 30 flowers in the garden. About how many weeds are there? The answer to that would be 75. Okay, this is your assignment right here. And it's just, I just put it on here. Let's take a look at A just to get you set up, because it says to draw a ratio box. So let's take a look at A. The ratio of boys to girls. So it says draw a ratio box. So I have boys to girls. Okay, make this into a box here, following directions. Boys to girls was 6 to 5. This is the ratio. I hate writing with this big fat marker on here. And then it's asking about actual count. If there were 60 girls, okay, now I want to make sure, do I put it up here or do I put it here? I want to make sure I'm putting it in the right box. If there were 60 girls, so I know how many girls there were. I'm trying to find out how many boys there are. So go through and figure out what fraction would you multiply this by, and then that should help you out. Oops. So that is your assignment. Finish just those 2 and then go on to Edmodo.